Give me just a sec. Let me know when you're ready.
Ready.
All right.
Okay. Hello, everyone. My name is Levi Zitting. I work at EmergenceMe. We're a startup here in the eFactory. And I'm here today to talk about EC2 Auto-Scaling. And I'm going to take a very kind of beginner-friendly approach in covering all the topics. I'm trying to assume as little knowledge of cloud services as possible, because I know that there's sometimes beginners come to these meetups and don't totally understand everything going on inside of AWS. So I'm going to start very basic. Who here knows essentially what a virtual machine is? And I'm pretty sure everyone gets that. So EC2 is Amazon's virtual machine service. They will automatically spin up virtual machines at your request. And that service, EC2, stands for Elastic Compute. Auto-scaling is the concept of automatically creating those virtual machines, a service that will do it for you depending on some type of metric, whether that's CPU utilization or requests coming in through something like a load balancer. Auto-scaling is the concept of automatically creating virtual machines to handle that kind of load. There's four resources to be aware of inside of the EC2 dashboard to understand how auto-scaling works. And those four are load balancers, or specifically application load balancers, target groups, auto-scaling groups, and launch configurations. And we're going to cover all of those. I'm going to give a real high-level overview of what all those are. So let's start at the top with the target group. So target groups is a resource in the EC2 dashboard to define, they keep track of a set of targets. Those targets are usually instances. So they know what targets are available to receive traffic. So they can a target group can essentially take in a request and forward it on to one of those targets, generally instances. Now that targets are described, let's go a higher level and talk about an application load balancer. So an application load balancer I like to think of as kind of like a router inside of like a web application. It has a set of rules that define where it should route a request. And when it routes a request, it forwards that request onto one of those target groups. And then those target groups understand which individual instance to send the request to. Load balancers can do a couple of other things, like handle redirects. So if you need to forward HTTP traffic over to HTTPS, a load balancer can automatically handle that. If you need to send requests from one domain name to another, depending on certain rules, an application load balancer can handle that kind of stuff. Then jumping kind of back into some of those more granular resources, we have the actual auto-scaling group resource, and there's actually a place in the dashboard called auto-scaling groups. And an auto-scaling group is responsible for creating new EC2 instances and monitoring some metric on those EC2 instances, and then responding to that metric. So an auto-scaling group will have a scaling policy that defines when it should spin up a brand new instance. The auto-scaling group is also responsible for registering that instance as a target with the target group. And then last is the launch configuration, which is a pretty straightforward thing to understand. It is essentially all the information the auto-scaling group would need in order to launch a new instance. So the launch configuration stores information like what type of instances are you trying to start up? What security groups to automatically add to those instances, what tags to add to those instances, that kind of information. It's essentially, if you've ever gone through the process of creating a new instance from scratch, a launch configuration is essentially that whole flow of creating a new instance. Okay, so. Sure, pretty sure you can, yeah. Okay, so to get started here, I am in the AWS dashboard, or AWS console, on the EC2 dashboard. So services, EC2, the most prominent one. And if I scroll down, we're going to start by creating the load balancer. And whenever you go through this stuff for the first time, it will kind of create some of these other resources for you. So you can't have a load balancer resource without a target group to forward traffic onto. So as we create our load balancer, we'll also kind of go through the setup screen of creating a target group. Same thing with the auto-scaling group. As we go through creating an auto-scaling group, we'll actually have to start by going through the whole launch configuration process. Some of these resources are required in order to spin up other ones. So down here on the bottom, on the sidebar of the EC2 dashboard, I went to load balancers, and I'm going to create a brand new load balancer. And we're going to choose the application load balancer. Not really going to go into any of the other types, really. So the first thing we need is a name. I'm just going to call this like production. I might have like a separate load balancer for my staging environment. This is going to be an internet-facing load balancer, so it can take in requests from the internet. Right here, we add a set of listeners. There's really only two types of listeners in an application load balancer. Those are HTTP listeners and HTTPS listeners. So the load balancer is essentially a server out there that's going to be listening on port 80 or port 443 and then forwarding traffic from there. So I'm going to add an additional listener for HTTPS. And then we also have to put our load balancer in a couple of availability zones. It requires that you select at least two. So I'll just select US East 1, A, and B. Next, we have to give our load balancer an actual security group. So if you've never even heard of a security group before, it's essentially a set of firewall rules for some resource in AWS. At least that's how I like to think about it. Oh, sorry, this is not the security groups. Step ahead of myself. This is the security settings where we attach an SSL certificate to our load balancer. Because I added the HTTPS listener, we now need some kind of SSL certificate for it to use. So I have a wildcard certificate that I generated using Amazon's certificate manager service. They will give you free SSL certificates to use within AWS, including wildcard certificates. So I'm essentially just attaching a brand new certificate or an existing certificate to this load balancer so it can use that to de-encrypt traffic. Now we'll go on to the configure security groups. And like I mentioned, essentially just firewalls for resources in AWS. So they decide which ports are open to the world. So I have an HTTP and HTTPS security group set up that has port 80 and port 443 open. So next we'll go to routing. So now we're getting into creating the new target groups. So it needs at least one target group to send traffic onto. So I'm going to call this ASG demo. It is going to target EC2 instances, so I select that. And this right here is a little bit interesting. Once a web request has come into the load balancer, I mentioned that I attached an SSL certificate to the load balancer itself. From that point on, we are in AWS. Our web request is in AWS, and we no longer need to encrypt traffic. And so what's happening here is we are just going to send the decrypted version of the web request onto the actual instances. So our web server running on our instances or our application doesn't actually need a copy of the SSL certificate, and it just needs to listen on like port 80. Right here, this is health checks. So this is something the target group will use to decide if an instance is healthy and ready to receive requests. So we just provide it a path, and it will try and hit basically that server's IP / and then that path, and you could maybe set this up as an endpoint in your application to check various services and make sure they're up and running. And as long as this returns a 200 OK response, the target group will assume that that instance is healthy and will forward web requests onto it. Right here in this register target screen, this is where we could manually add targets, like maybe existing instances we've already created. We're not going to do that because when we create our auto-scaling group, we will then create the connection to this target group, so any new instances the auto-scaling group creates will automatically be registered as targets here. So I'm going to skip over this and go ahead and click Create. Now, one thing I'm going to do right now so that the demo works later is walk through, instead of going into creating the auto-scaling group, I'm going to walk through what it looks like to hook like a domain name up to a load balancer. So right here, I'm looking at the load balancer itself. And maybe the first thing I'll do is show off the listeners. So, and show off like the rules that we can create for our load balancer. So right here, we have an HTTP listener. And I can come in here and see that this HTTP listener is just forwarding traffic directly onto the target group. I would probably want to do something like enforce HTTPS, so I can come in here and edit this rule. Instead of forwarding the traffic, I will redirect to the HTTPS version. I have to enter in the port number here. So now it's going to return a 301 redirect that says to always go to the HTTPS version. So our normal HTTP listener really isn't that fancy. And then I'll jump back and look at the load balancer. Also, here's where I could add more certificates if I had additional domain names I'm trying to handle. And then if I look at the rules for the HTTPS version, it's just forwarding onto the target group, which is exactly what we want. One thing that I've come across is, a load balancer is kind of an expensive resource. I think it can run upwards of isn't it 30 a month or something like per load balancer? And so the good news is you can have up to 100 different rules in here or something like that. So you can have one load balancer managing different applications. You don't have to create a different load balancer for every application. We found it handy to create a different load balancer for different environments since we had those behind separate VPCs, but not a separate load balancer for each individual project. Okay, so now if I go over to this description tag, one of the options in here is this DNS name. And this is the domain name essentially for this load balancer. So if I want to send traffic from one of my other domain names to this load balancer, I would need to create a Cname record pointing to this domain. So one thing I'm going to do is jump over to DigitalOcean where I have the DNS records for my main domain name stored. And I'm going to update this ASG demo record to point to this new load balancer. What was in there before was a load balancer I set up while I was initially creating the demo. So I'm going to do that right now so the DNS has a few minutes to propagate. It may not even end up working. I set the TTL pretty low, so it hopefully switches really soon. One thing to note, this is something that I've run into before, is this load balancer does not have an IP address. It only has this DNS name. And one thing you could run into is limitations with adding Cname records to the root of a domain name. So if you want to point example.com to your load balancer, you actually can't normally do that because it's against the DNS spec to actually have root Cnames. Some DNS providers will let you do it, but it's technically incorrect. Usually the solve for this problem is maybe actually having the www version of your domain name point to the load balancer and set up a redirect, so any traffic coming to the root domain goes to the www version. Or if your DNS provider supports it, there are a couple of new record types that support a Cname-like value for the root domain. So name.com has the aname record, which is I think something they created, where it will actually go and resolve the IP for the value that you set in the record name and give you back. It'll actually represent just the IP addresses to the outside world. And so it technically works.
And if you host your DNS on Route 53, the AWS DNS, you can point that Apex domain or just domain.com to a special alias record.
Right.
And then the drop down will show your load balancer as an option.
And even if your Route 53 lives in a different AWS account, you can paste that URL in there and it'll still work. So there's another alias record type when creating a new SNI?
SNI.
No, what is that?
Server name indicator. So it's basically you have so you could have this load balancer and point 100 domains to it.
Uh-huh.
And so with SNI, and Amazon supports it. I was looking at it the other day.
Mm-hmm.
Interesting.
Yeah, so it basically, you have to pass as part of your connection, you pass the host that you're looking at,
Mm-hmm.
the host URL, and then it resolves it within the IP.
Interesting. Cool.
Yeah, so SNI is what it's called. It's starting to be, this is a security deal, so a lot of people are implementing it.
Interesting. Cool. Good to know. Yeah, the Route 53 alias record type definitely works. That only works with Amazon resources though.
Right.
You can't point any old domain, treat it like a CNAME essentially. And then I know Cloudflare has like virtual CNAME records that do the same thing.
And what he was suggesting was on the load balancer,
Mhm.
you can actually bind multiple SSL certificates to the load balancer if you want to accept SSL traffic for multiple host names. I don't know
Yeah.
if you knew that because you have the wild card.
Right, but that is something I was aware of. You can attach as many SSL certificates as you want as
That's
well.
what SNI is.
Wait, what?
You're limited to 25
25,
certificates
that's
per
right.
load balancer.
So
Got
he
it.
knows the limit. That's
Got it.
awesome.
Got it. Cool.
Run into it.
Yes, we did.
Wow.
Good for you.
Well, we haven't run into it. We would have run into it if we didn't bundle certificates.
Got it.
Yes.
That's another secret too, is that you can bundle your
Mhm.
certificates
You can have multiple names
with
in
the
a cert.
certificate.
Yep.
manager, so.
Exactly.
Love it.
Okay. All right. I think we're ready to jump over to the actual like auto scaling group setup. So I'm going to come down here to auto scaling groups. And I haven't created one in this account yet, so I'm going to go ahead and click Create Auto Scaling Group. And it's telling us that first it's actually going to go through and create a launch configuration, because you have to have one of those before setting up an auto scaling group. So I'll go through this. The first thing it asks is for the AMI, which is essentially just a disk image, an operating system image. You can use any of the Amazon ones. I created one that's based on Ubuntu that has like a simple Nginx server hosting a PHP script that'll spit out the server IP in the like HTML that comes back so that we can refresh the page and see that we're getting to a different machine every time.
Quick question, what's an AMI?
So an AMI is a disk image, essentially, just an operating system image.
What are our options?
What do you mean our options? Like
Windows, Linux?
essentially anything. They provide a whole bunch of them. So if I come back over here to Quick Start, the most popular one is Amazon Linux, which is a special distribution of Linux for Amazon use in AWS, but you can find Ubuntu, Windows, really any kind of operating system. And I'm pretty sure, correct me if I'm wrong, Jason, but you can upload your own, can't you?
Oh yeah, it's very common to roll and maintain your own on larger environments.
Sure, yeah. So then if I come back here, like I mentioned, I had created this one earlier, and I gave it the name Golden AMI. This is something I've seen before in auto-scaling group setups. The AMI that you base all of your auto-scaling groups off of is the Golden AMI, and you'll continually reuse that one. So after selecting the AMI, we select the instance type. So I'm going to just go with the one that's available in the free usage tier. For now, we don't really need any crazy resources. The launch configuration name, I will just call this ASG demo. And one thing I'll say about launch configurations is you can't edit launch configurations. It's a very annoying thing about launch configurations is you can't edit them. You can only copy them and create new ones. So what I normally like to do is add the date to the end. What's the date today? 13. So that I know which one is the latest one that I'm working on. Okay. I'm going to skip through the rest of that stuff. Here's where I would attach a storage volume. This is very, very similar to the setup process for like a brand new EC2 instance. Here we attach a security group. I have one that opens up the SSH port in case I need to jump into the instance, and port 80, which the load balancer will forward traffic onto. And here's our review screen. We'll go ahead and click Create Launch Configuration. Also, just like with EC2, especially when you have the SSH port enabled, you have to tell it which SSH key pair to use, and that key pair will then be copied over to the individual instances as it spins them up. So now we'll go ahead and click Create, and now it's taking us directly into the auto-scaling group setup. So I'm going to essentially do the same thing, and we can see that it's automatically connected that launch configuration. So I'm going to call this ASG demo. We'll start with a single instance. And right here where we choose subnet, these are the subnets that it can launch instances into. And earlier, when I created the load balancer, I had to choose which availability zones the load balancer was in. So I need to make sure that my auto-scaling group is in those same availability zones by selecting the appropriate subnet. So if I come in here, there's B and A. So now my instances are only launched in the availability zones that my load balancer supports. Next, we have scaling policies. I'll go ahead and create one. I'm not going to go super deep here. There are quite a few options, but kind of probably the most basic one is just based on CPU utilization. So as soon as an instance gets above maybe 50 or 60% utilization, you go ahead and have your auto-scaling group automatically spin up a new instance. Scale group size, we'll say 60% or something like that. You have to enter a value in here, basically a cooldown period before that instance. Oh wait, no, that's not what that's for. Or is it?
That's for starting up, like if
Right.
it needs to do a lot of processing.
Sure, you probably increase
You
the-
don't want to have it go above 60 and then it's like, oh, it's working too hard, I'm going to scale up another, and it just
Oh,
snowballs.
interesting. Yeah, gotcha. Okay, that makes a lot of sense.
To happen.
Another thing I'll mention, when I was initially thinking of auto-scaling and jumping into all this stuff, I thought of scaling up and scaling down. I think what maybe many people's mind kind of go to that, but that's not how AWS refers to scaling. It's scaling out and scaling in. Scaling out creates new instances, scaling in deletes new instances, or deletes old instances. So right here, we have the option to disable it deleting all those older ones if we needed to.
I can't read it. Is there a max on there?
Right, at the top you have between 1 and 1.
Oh, yes, totally missed that part. I'll zoom in
Can you
here.
zoom in a little?
There, that's better.
Yeah, so this is basically our where our instances should live, so we don't spin up 300 on accident or something like that. I'll actually set this to maybe 4. Okay. One thing we can do is set up notifications through SNS. So we can, whenever a new instance gets launched because of auto-scaling, we can get a notification. Whenever an instance fails to fails to start up, or an instance is terminated. Here's actually our options here. So on launch, on terminate, fail to launch, and fail to terminate, we can get notifications through SNS. Not going to set that stuff up yet. Going to skip over creating any tags. And we should be good to go ahead. Actually, okay, I did enter in a value there. Go ahead and create the auto-scaling group. And it looks like it worked.
That's fast.
It was fast. So it just created that auto-scaling group resource. It still has yet to go spin up the instances underneath the hood. So that might take a second. So right here, we're actually looking at the auto-scaling group itself. And we can see here there are currently 0 instances, but we have like 1 desired. So if I hover over here, it's saying that an instance is in the process of starting up. And if I come over here to this instances tab, we should see an instance starting up right here. Now, one thing that didn't come up in the setup was connecting this auto-scaling group back to a target group. So as the auto-scaling group is spinning up this instance, it isn't automatically registered with the target group yet. So if I select the auto-scaling group and come into Actions, Edit, we'll see here target groups, and we can select our ASG demo target group that we had created earlier. So now if I save this, when the new instance comes up, it should be registered into the target group. Let's see if that did that right away. It might take a minute. So if I go to target groups now and go to targets.
How many times have you ran through this? Because this is kind of like, this is getting into it.
How many times have I ran through?
Like done this. Do you do this at work? Do you?
I did it quite a bit. Like I did have to do this quite a bit. Like I spent probably a couple months digging into all this stuff and trying to understand it as we were doing a big migration from like shared EC2 instances where we had multiple websites hosted on the same server to more of where each one is on its own auto-scaling group. So definitely have had to do this quite a few times. But we can see here, now that I'm looking at the target group, our target was automatically registered now that I made that connection. I also want to show what it looks like to kind of manage like how many instances an auto-scaling group should keep. So if I come back in here, like let's change this from 1 desired and 1 minimum instance to be 2 so that it will automatically spin up a new one. So if I come up in here and go to Actions, Edit, right here we can change. So I'll change this to be 2 instances, still a max of 4, and we'll see this little icon shows up saying it's spinning up new instances. And we should see if I refresh in here, it might take a second, a new one based on the AMI is automatically getting spun up. while that's doing that, I also want to point out some actions you have available in here that are kind of handy. So let's say one of these instances is having problems, and you need to like SSH into it. One thing to keep in mind is that these servers, these instances are ephemeral, which means they could disappear at any point in time. Like you could be SSHing in, trying to debug something, and it disappears from underneath you. So if I come over here and check this box and go to Actions, Instance Protection, I can set scale and protection so that as this auto-scaling group is scaling in and out, it will not touch this one, which is really handy when you're trying to debug stuff.
It won't do it while a task is operating, right?
Oh, yeah.
Yes, it will.
Are you serious?
Oh yeah, it doesn't know what's happening on the machine.
It just knows that you're under your whatever threshold.
Right,
you're
those
scaling.
numbers control everything.
So if you're doing something transactional, it could just kill it?
Yes. Yes, it could. It's definitely something to be aware of.
'Cause everything we do is transactional. I mean, everything.
So that's kind of where you start to need to introduce like some more cloud services into your architecture. I actually had a note to touch on this and I skipped over it on accident. So these servers are once again ephemeral. You can't depend on the file system of these servers actually being there. So you can't install, and not only can you not depend on the file system, each of these servers should be somewhat idempotent, where like, I guess maybe that you could use that to describe it, but you can't have data that lives only on one of these servers. They need to be the same across all of them so that any request going to any one of them, it doesn't matter. So, for file system access, like if you need to store a user uploaded image, you're going to have to introduce something like Amazon S3 in order to handle that. For database access, you need to hand that kind of stuff off to like RDS, or just have like a separate server that isn't in an auto-scaling group that runs that
Right,
database.
but that's not the problem, though.
We were looking at, so you initiate a request, so we have an outside,
Mhm.
initiates a request, hits our API, hits Docker, it's transactional, some processing is done,
Mhm.
then it hits RDS, stores the database transaction, hits S3, stores the physical component of that transaction, comes back, and out it goes. And that transaction can't die in the middle.
Right.
There is a cooldown period. When it's scaling in, you can set a cooldown period so it will unregister from your target group and not accept any more incoming requests, and then maybe wait 60 seconds or 180 seconds or 300 seconds, whatever that cooldown period is, before it kills it off. So if you have things that are sensitive to transactions or state in any way, but you are confident in an upper limit of how long those might run, you can adjust that cool-off period so that they'll get killed, but theoretically all of those pending requests
They call that draining.
yeah, well, that's
But-
probably what they call it in AWS too, but
Do
that's,
you have to, can you only do it by seconds, or can you specify by process?
I don't know.
Yeah, I'm not sure on that either.
Seconds.
It's definitely something to be aware of,
Yes.
because like it does introduce some complexity and some other problems to solve there.
Because everything we do is transactional. We have
Right.
a GUID that's tied to each transaction, and it doesn't matter what we do, even if we don't hit, whatever. Every process that hits is
Sure.
transactional.
Right.
It has to execute, or we know why it's not.
Mhm.
And we dig into it.
I wonder, Jason, let me know your thoughts on this, but like maybe it's time to introduce, for like those kind of problems, you could introduce like that. Maybe that sounds like it could be like a background job running an SQS or something
Yeah.
that runs all the way to completion.
Right, but even our things that are SQS based are running on containers that scale, and we've tried to design everything in such a way that it will run at least once and is allowed to run multiple times.
Right.
Like our platform is smart enough that it can deal with duplicate queue jobs.
Yeah, sure. Yep.
But then that way, if something gets killed off or dies and it's committed to the database but maybe hasn't finished posting something to S3 or whatever might be related to that job, it has not gone into the queue into SQS and said this job is complete. So then when it got killed off, eventually that job bubbles back to the top on SQS. It's invisible for a while in the queue because it's being processed, but once that timeout hits, goes back into the queue and another worker can take it on and figure out where it left off. All of our code is set up to deal with multiple runs.
So you're saying with a monolith application and you're doing auto scale on that, you'd want to have some sort of outside queue service to keep things in there.
That's how we've handled it. Yeah, it's worked real well for us
But how,
actually.
that wouldn't work with WebSockets, right?
No.
Mm.
No. Yeah.
Probably not.
Yep.
I say that, I think ALB, the load balancer, I think it has a way to deal with sending some WebSocket traffic to different target hosts. I don't know the details, but I think they've introduced a way to deal with scaling.
Mm.
So you'd have to read up on their solution. There might be a solution there.
Sure. Okay, so jumping back into this.
Sorry.
No, you guys are totally fine. Questions are great. So I think everything is done at this point. We've set up all the resources, so now we are good to auto scale. Let's see if the demo I had is working. Yay, it is. So as I refresh here, we'll see we get a different IP. It goes from one machine to the next and back and forth for every single request. And normally, I'm pretty sure the target groups follow that pattern of sending to each server in succession. It doesn't try and do anything smart there. There may be some different rules you can apply, but I'm not totally sure. So I had mentioned that I had an AMI with the code for this demo on it, but that is definitely not a way to try and get application code into an auto-scaling group by any means, because it is a pain to actually try and replace, a little bit of a pain to replace the AMI that an auto-scaling group is using. The AMI is chosen when you create the launch configuration, and like I said, you can't edit launch configurations, so you have to copy, choose a new AMI. Also, creating an AMI is just not super easy. It takes a little bit of time. So it's not an easy way to deploy new changes to your app. So that's where you would probably need to use a service like Code Deploy if you were deploying directly to the instances. Code Deploy has some integrations with auto-scaling groups. So when you go create a new Code Deploy deployment, it will add a lifecycle hook, which is over here. I don't have any right now, that tells the auto-scaling group whenever it spins up a brand new instance, it should automatically deploy the last thing that was deployed from Code Deploy. So you don't need to embed any application code in the actual AMI. You should really just have like system level software installed there. Also, another thing that's really handy with the scale-in protection is if you are trying to update your AMI and you need to essentially cycle out all of your old instances, you could come in here and change your, essentially you would come into the auto-scaling group and double your instance size. So I would change this to be 4 and then come back and set scale-in protection on the new ones that are created and then set my lower limit back down to 2 and the old ones would get removed after that. The ones with scale-in protection wouldn't be removed. So something to know if you ever need to go through and update AMIs. I think that's basically it. It's a pretty short presentation, but I'm open for any questions if anyone has anything else.
I like the dating of the deal. It would be nice if they had a drain, just a check mark to drain it and say, here's a new configuration, drain the old ones. Boom.
Yeah, sure. I'm pretty sure I've seen like a connection draining option somewhere. I cannot remember for the life of me where it is.
I thought so.
So that may be something that could solve that problem you were running into. We could go, it might be in the target group. So if I come in here to go edit the options for the target group, let's see what we can find. I guess I have it selected.
And that's how we always cycle servers.
Attributes, maybe?
Edit attributes, let's see.
Back in the days when we had physical load balancers.
Is it the deregistration delay?
I think that could be it. I think that may be what you were talking about.
That's what I was talking about.
Yep, I think this is probably what I was talking about. Stickiness, where it will use a client session to try and decide, like always send requests to the same instance, which I could see some benefit there. But yeah, I don't think there is actually like connection draining, sadly.
Stickiness is nice, especially when we're doing like you're loading resources.
Mm-hmm.
So and you could have a lot of resources out there, and then maybe they're memory intensive.
Sure.
But you load 1 or 2 that you're working with, and then if they come back and it's sticky, it's really good.
Yeah,
You're not
definitely.
Continually reloading those resources on other instances.
Yeah, exactly. Any other questions?
You mentioned, this is probably more of a comment than a question, but you mentioned the health checks on there, and I noticed by default the health check checks / or your sort of
Mhm.
home page for a code 200. Have you done much with custom health check pages, or have you?
I haven't. I can
Done
see
anything
where,
there?
yeah, I can see where the connection could be made. Like have just an API endpoint that tries to do basic system
Right.
health checks and makes other requests even. But no, I haven't really tried to set any of that kind of stuff up.
I have noticed on some frameworks you can get plugins that will run health checks that probably aren't intended for this, but they will return different codes if there are problems with, say, the database or the
Sure.
cache or whatever. So for anybody who happen to be running a framework on EC2 instances, definitely consider that. It's
Sure.
a good way to give you more than the servers up.
Right. I think that might be for a different use case because
Okay.
it's really meant to determine if the instance itself is healthy.
Yeah, but if your application is not healthy, you don't want to send traffic to it. At least that's part
Yeah,
of it.
I guess, but it would take down other instances. Like you could get into a loop where it just starts spinning up new, because if a health check fails for long enough, it will spin down that instance
Right.
and try spinning up a brand new one.
You're
And so you
right.
could get into this loop where it's just sitting there spinning up new ones. So it's mainly there to make sure that like the last code deployment was successful. I could see the you wouldn't want to send any traffic to it if it's not healthy at all.
Right.
One thing I'll mention with the health checks that we kind of ran into, we weren't totally able to use the health checks because of how our web servers were configured on the instances, but the host header for the health check will just be the IP of the machine. It won't be like your application's domain name. So you'll have to make sure that your web server is actually able to take in requests. In Nginx, we had specified the domain name in all of our Nginx configs, and so our health checks weren't actually. They were just going to the default, like Nginx default server landing page or whatever, instead of like actually loading our app. So they weren't actually providing as much helpfulness there. So that's something to be aware of, is that the incoming request will be the machine's IP / the path.
What were some of the other options for scaling besides CPU? I know we sort of glazed over that, but
Yeah, I did. I haven't. That's something I haven't dug into really.
Okay.
Most of the time we were depending on just CPU utilization is what we were watching. I know you can. Let's just go through or no, I don't have to go through there.
because
I
that's
can.
what we've done too. That's why I was curious.
So I'll go to add scaling policy here. So here's some basic options. So network IO, just number of requests per target. So if it sees that many targets are getting a requests over this amount in a certain minute, maybe, I guess.
And I guess you could do more than one too, huh?
Yeah,
So
you
it's
could have
like,
multiple scaling
even if it
policies.
hasn't hit CPU yet,
If you know
if
you're
you
getting too
see
many
that-
requests.
Yeah,
Mhm.
you can
That's
trigger it
cool.
there, too.
Yeah, we've only used CPU. That's why I asked in case you had if anybody had looked
Right.
at any of these. Very cool.
Okay. All right. Well, if anyone has any more questions, I am in the web devs Slack and always open. Just DM me in there, or just start up a conversation in the AWS channel.
All right. Thanks, man.
What is the web dev Slack?
Web devs.
Yeah, the easiest place to get to it is go to SGF webdevs.com. Yeah,
And then click Slack.
this guy right